Or lesson 15, internal corrosion. Introduction. Even the bulk petroleum product they have consumed that must be handled at many times with the build up the internal corrosion pipeline result of the decree that throw out with the increase the plant with the combination of the products moved and remove the pipelines if the caution. Called the internal corrosion water with the electrolyte with all the fuel system that all outlet drains during the change of the temperature of water several of the low points of the pipeline where it contributes to corrosion of the pipeline inner surface. Oxygen is present where combined with water and the paraffin and waxy substance that obtained with the petroleum they are present in the fuel that also contributes to corrosion. Middle scale abrasive for the solid or surface the oxide film. The scale is not in metal but electrically conductive, which is harmful to the more noble or the metal with the means that will wear break for the middle scale will occur. The corrosion will happen. The metal is an anoid. The middle scale is a cathode. Combination of the elements water, oxygen, and abrasive heat from the friction in the pipeline as in the fuel is moved in the pipelines as speeds of the corrosion process. Effects of internal corrosion. Decrease the throughput. The buildup of the material wax mill scale of the inter pipeline occur with the degree and quantity of the products received at the pipeline compared with the path. The increased maintenance. The degree of the volume takes place with the action of the compensate with the increase of the discharge pressure may be taken if there any action there is a counter action will increase the pump with the discharge there will increase the maintenance requirement of both pumps as well as the pipeline. Possible product contamination. The presence of water, heat, solids will affect the product and cause the loss of the property possible microbiological growth. Methods of preventing corrosion. Remove water. Fuel with the discharge with the should always be issued with a filter separated to eliminate water and solids. To remove the oxygen, fuel can be packed with the air eliminated where pocket of the air can be eliminated with the removal of the oxygen required with the fuel be heated that is not processed or employed in the military. Use inhibitors from the hidden proactive film on the pipes, the pumps, and tank with the other metal surfaces will comes in contact with the two types of inhibitors available. The only one that is used in the military pipeline. The inhibitor is water soluble, oil soluble. Alright, water soluble inhibitor. Water soluble inhibitor is not even the military system. It would be to remove the when the fuel is passed through the filter separately, thereby not eliminating corrosion. Oil soluble inhibitors is used when required. Products such as motor gasoline, diesel fuel have the inhibitors added by the manufacturer. Only jet fuel does not have that added. If the laboratory test shows the need for inhibitor, the quantity they require to inject them along with the product into the pipeline, the inhibitor ineffective to prevent corrosion with the cleaning metal will prevent further corrosion on already corroded metal will prevent the rest in the metal scale to a small degree. The oil inhibitor can be passed to the filter separately without removal of the inhibitor. Using internal corrosion or Teflon, the addition of the coating of the pipe interior with expensive for the military, the procedure will be used in some of the commercial industry for the chemical steam. The surface of it will be economically advantage of the type of the material corrosion resistant, the only where the material has been damaged to corrosion subject to occur. Use a non-metallic pipe with the material plastic fibers, but graphite as well as the other materials developed in the future. Maybe they may cover the pressure type of the surface requirements hot and air to cold. The type of the materials are non-corrosive. Use of scraper. The scraper will remove the building up of the interior of the pipeline, the corrosion and be controlled with the pipeline over the period of time. Clean have the inside of the diameter enlarged and the scraper to run to. They frequently additional with the wall thickness reduce the corrosion can be weakened and the pipeline cover the breaking. Note, the scraper program should be set up based on the need such as the decrease the throughput and increase in pressure to maintain maximum flow to reduce the product contamination. Alright, measurement of an internal corrosion. Internal corrosion decrease the capacity of the line to effect the effect of the area of the line of the line and velocity of the line held and constant will decrease within throughput with the several equations having them commute with the fact that describe the condition of the pipe and interpret the describe the C factor for the commute with the observed with the head loft between the 2 points on the line or the condition follows. 1. When using an equation with the Darcy washbout, the compute with the head loft to do the friction with the friction factor, the new pipe known with the friction factor derived with the Darcy washbout the equation, the effect with the internal corrosion, the effect with the internal corrosion in relationship expressed with the Darcy washback equation. Increase the friction factor will result in the increase of the head loft as increase the effective diameter of the pipe with the result of the increased head loft. The actual reduction in the diameter might be small, but the reflective effect was great. No, given the flow rate without considering the increase of the roughness of the 2%, the decrease of the diameter, increase the pressure, drop to 10%, but the 50% decrease of the diameter, increase the pressure, the drop to 27%. Hayes and Williams equation possible, simultaneous, handy several equations where they describe a relationship with the factors govern the rate of the fluid flow through the pipeline. C factor equation will be the base and pressure for the loss per 1,000 feet of pipe. The C factor is based on the empirical scale, which varies 60 to 160, depending upon the smoothness of the inside of the wall. The smoother the pipe, the higher the C factor, then less the resistance there is flow. A coefficient of 147 with a new steel pipe, however, the factor may be increased with 150 or 160 throughout the use of the scrapers and inhibitors with the polishing effect for the inside of the pipe. The drop of the C factor due to the build up the corrosion product of the pipe results in drop in throughput. In 18-inch light with the C engine's line C factor drop to 160 to 150 there would be an annual loss throughout the throughput of approximately 4,600,000 barrels. The result of the derived equation less than 140 C factor indicates potential needed to schedule the shape of run could be for some other reasons, some partially closed value, other type of the rockets in the pipeline. The C factor formula is based on the pressure loss of the per 1,000 feet. The volume equation is used to determine the flow efficiency. C is equal to the coefficient of the corrosion. Q is equal to the rate of flow of the barrels per hour. D is inside of the diameter of the pipe in inches. And P is the pressure loss per 1,000 feet pipe length. And G is the specific gravity of the product. Alright, note in Formula 66 the constant with the Q and P with the raised to the power 0.542 with the raised P with the power to 2.63. The value used in calculating X is greater than or Y is greater than or less than the universal power key. The individual can compute any number of the raised power. The calculator example inside the diameter pipe is a D. And it shows these calculations and problems. Alright, 5. Elevation and pressure for the following procedure to be taken when they adjust the elevation difference based with the equation of the level of the pipe. The elevation difference between the upstream and the downstream of the points for the pipeline pressure read between the 2 points of the pipeline, taking the pressure gauge reflect with the pressure at whatever the elevation may be. The upstream elevation 800, downstream elevation 850. The difference between the 50 feet, and then it shows the examples in the notes. Note, with the pressure for the elevation, we can adjust the pressure reading tape with a 2 gauge for the pipeline to correct with the pressure for the pressure difference for the gauge, and then there's more problems. Alright, 6. The length of the pipe. The final factor to affect the result of obtaining the Hazen-Williams equation of the length. The equation based on pressure for the over length of 1,000 feet. The distance greater than 1,000 feet, you divide by 1,000 to arrive at the figure to divide the pressure. Note, alright, lesson 15. That was lesson 15. Lesson 16, external corrosion.